Shell method. Welcome back to Calculus 2, section 6.4, shell method. So now we're going to do rotations and volumes again, except this time they will be done from different perspective. When we did disk method in the previous section, we had the object rotating on the, let's say, x-axis, and we were cutting out portions that were delta x, or let's just put dx thin, obtaining disks. So we would have something like this, and let's just add some thickness to it, right? So it was a disk. I would say CD, but you guys don't know what it is anymore. You used to at some point. Now, with the shell method, we're going to get little shells because the same object, which is rotated on the x-axis, when I cut, I will cut this way. I will cut this way, obtaining little shells. So a shell that will look like this, and will have some thickness. So you'll see that we actually, here for this little thickness, we actually have dy. Now observe that both of these are rotations on x-axis. Default case for disk gives us dx, and the default case for shell gives us dy. So they're approaching the same problem from two different angles. Now, another thing that you can remember for disk method is that the representative rectangle is perpendicular to the axis of rotation, where for the shell method, representative rectangle is parallel to the axis of rotation. So now, the shell method has the formula, which I'm going to modify actually a little bit. Your textbook has, well, I'll give you the textbook first. So V volume is equal to 2 pi integral C to D y times f of y dy. So this is the rotation around x. Remember that when you have rotation around x, you have dy. And your textbook, so you can use either one of these two. I like the one that I'll give you better. This is the y rotation. So this is the textbook. The one that I like better is the one from the Larson textbook, which is a different textbook, which has this volume as 2 pi C to D P of y h of y dy, again x rotation, and I'll explain all of these. 2 pi a to b p of x h of x dx for rotation around y. So these are the formulas that we get to use to figure things out. Now, what is the meaning of these P and H? P stands for position, H stands for height, and you just look at the picture and its immediate answer. It's a little bit tricky with the formulas from the book because they're restrictive, because they're actually asking you to have x and a y there, but those could be also, if you shift function or something, it's just a lot of mess. The first problem I want to solve is the first problem we solved earlier for the disk method, which is the triangle. So I'm working on the same problem, if I can draw the line. I believe it was 2, 7, right? And we rotated it on x-axis. So the formula over here was y equals negative 2 over 7x plus 2. And we had an answer, something. What was the answer? 28 pi over 3, thank you. So we know where we're hunting, right? 28 pi over 3. We're just going to do this using shell method. So for shell method, we need our axis of rotation to be parallel to the representative rectangle. So it's going to be dy this time. And now we have to set up the dy integral. So we have 2 pi. So this can washer method have pi times the integral. The shell method has 2 pi times integral. So remember that. Integral from 0 to 2, because the bottom rectangle starts at 0 and it goes up to 2. The position function p in this case is just y, because it's swiping all of the values from 0 to 2. And then the height of the rectangle is going to be the function, but we have to solve function for y, because the integral has to match. It has to have y limits, it has to have functions in terms of y, and it has dy at the end. So we have to massage this, right? Get the x equals in terms of y. So we have y minus 2 is equal to negative 2 over 7x. So x is equal to, multiply by negative 7 over 2. So negative 7 over 2 y plus 7. And that's what we plug in here. So I have negative 7 over 2 y plus 7 dy. And now we compute this. Now you would say this is more work. Of course, because this is not the problem that this should be used on, right? There are other problems that we use shell for. But I just want to demonstrate that we get the same answer, and we move along with other examples. So 2 pi integral 0 to 2, we get negative 7 halves of y squared plus 7y dy, and now it's time for us to integrate. So 2 pi integral is going to be negative 7 over 6y cubed plus 7 halves y squared from 0 to 2, 2 pi. And now we plug in 2, so that's 8, cancel one of these, so 3, so 4, so negative 28 over 3. Plus, plug in 2, that's 1 cancels, 1 stays, so 14. And that's it, right? That's all I have. Zeros will kill everything else. So now I have 14 over 3. So 14 times 3, that will be 52. Is that true? Something like that. So 2 pi. No, times 3, right? 42. So 42, yep. 42 minus 28 over 3. That gives us 14. 28 pi over 3. Awesome. So we have the same answer. We have to, because we are just using a different method to solve the same problem, because we could. But there will be, again, those problems that will not be possible to be solved by both methods. Yes?
At the very top, why did you need y alone? Right before negative 7 over 2?
This one? That's the part of the, sorry, this one, P of y, position. It's the position. It's what values are swiped by the representative rectangle. It's swiping all of the values from 0 to 2. So that's that pi with the position. Let me just give you an example when it's not going to be that. So say that you have this situation. This is the axis of rotation. This is where the function is. So now when you have a representative rectangle, you see that this is where 0 is. Let's say this is where 1 is, and this is where 2 is. The representative rectangle, the axis of rotation and the x-axis are not in the same spot. So now when you put in your p of x, is going to be y minus 1, because you don't take care of this, because it will not be swiping this this region. It will just swipe from 1 to 2. So it will be integral 1 to 2. You have your 2 pi and so on. You have this, and then whatever the function is, and then you have your dy. So when the problem pops up, it will be clearer. The book, actually, I don't think that actually there are any of the problems that are accommodating this, because your book tells it's always y, f of y. So, and I think in the more advanced exercises, they give you to kind of break your head a little bit about this stuff, kind of stuff. So for the 90% of examples, that y will be there, just y, but it could be, depending on which side of is the right. It could be on the other side of x-axis, and then it's even more away, like 3. So there's a lot of things that could happen. Let's take a look at some examples from textbook. So I love this example because, well, actually, here. Y Yep. The hell? All fixed. That's the beautiful thing about Microsoft products. When you know something about Word, you fix them. When Apple crap breaks, you just throw in a garbage and you spend another $1 million on a stupid product. All right. So let's take a look at the at this problem. So we have, this is problem 6. Y equals negative x squared plus 4x plus 2. And then we also have y equals x squared minus 6x plus 10. The graph for this, and we are rotating on y-axis, y rotation. So the graph for this, it's not going to be terribly precise, but it looks something like this, where these intersection points are at 1 and 4. We are rotating on y-axis. And if you take a look at this picture, there is no way that you can use disk method. Disk method is not possible in this question at all. Because if you want to use disk method, you are rotating on y, you must use what? Dx or dy? Dy. Look at me drawing dy. It seems like it's okay, right? Left-hand side touching this function, right-hand side. But look at this one. Touching the same function, right, on both ends. It cannot be used. Over here, I can draw another one. Touching the same function on both ends. Cannot be used. So you are not going to start the problem by trying to figure out, is it disk or shell? You will actually look at the picture and you will say, I can put dx or dy or both. If you can work with both, well, then you can pick a method. In this case, the only one that you can put is dx. Now, dx is parallel to, and this is what you're remembering. So it's concepts, guys, not mechanics. Concepts you're learning in Calc2. So you are going to say the representative rectangle must be, in this particular example, parallel to the axis of rotation, which is exclusively shell method. So you are setting up shell. When the situation is either way, then you do whatever. Now we're going to see examples where, say, disk method has two integrals and shell method has one. This would be, this bottle that I'm having here would be that particular example. Because if you take a look, this is one type of a function, linear, and let's say that this is maybe exponential, okay? So going in this way, you have to do integral for this function first and then integral for that function, which is two functions. But the inverse of exponential is log, and if you do the dy, you just get to do dy, and this piece becomes the limit because you're doing dy, so it goes from 0 to whatever the hell this is. So in this particular object, you would have to use disk done twice for two different functions, or a single shell. So both are possible. It's just what's more convenient to do, two integrals or one. However, in the problem that you are looking at right now, you are forced to use the shell method because you've seen that disk is not possible at all. So now what we do here is we set up our integral. You have that we are using dx, so volume is 2 pi integral 1 to 4 because the representative rectangle is going to swipe all the way there. It's swiping off x, right? That's the position. And then you have the height. The height is top minus bottom, which is the minus x squared plus 4x plus 2 minus x squared plus 6x minus 10. I just flipped all the signs already, so I'm not writing this 15,000 times. Get the like terms and multiply by x and then integrate everything. So negative x cubed, 10x squared, so plus 10x squared, 2 minus 10 minus 8x. So what I did is I added like terms and multiplied by x in front. So minus x squared is minus 2x squared times x is minus, the hell I did over here, that's wrong.
Minus x squared is
Minus 2x squared and then times, so there's a 2 that's missing over here. There we go. So minus 2x cubed. Awesome. All right. So what is this now? 2 pi. We have x to the 4th over 4, so negative x to the 4 over 2. plus 10 thirds x cubed minus 4x squared from 1 to 4. And that's a number at the end. There you go. Whenever I say that's a number at the end, that means that you will be redoing this problem at home, all right, to practice, and then you will work it out to get whatever the answer is. This was, this could be a homework example. So learning the concepts is important. Okay. We have another like 3 hours of class. All right. Let's do then the longer example. He doesn't know. I saw that look. Because I'll stay at house. So for this problem, it wouldn't be fair to say, one side of the room do shell and the other side do disk. So clearly both are possible, and because it wouldn't be fair, that means what? One is easier than the other, right? So I'm just going to leave it to you individually and say good luck, right? So you guys figure out. So y equals 8, y equals 2x plus 2. I'll do both eventually. X equals 0, x equals 2, rotation on x-axis. Good luck.
You got the basic idea. Like I don't think it's like oh. I don't know. I feel like he's like doing one of those. So if the rotation is y, this means y axis is the rotation. Yeah, that's why. If you put that there, no, if you put the lines next, then it'll be, then there will be red. What I do.
How do you know?
This stuff is high level. The problem is both ways have to give obviously the same answer.
So 8 minus.
You see how that one is the one.
Thank you. 8 minus.
We're doing shell. Yeah, I just and then. Yeah, you gotta get over it. Yeah, that was what I said.
Choose 8 minus.
Now, guys, one of the big traits of engineering is draw big. You get those square notebooks because the line paper, I get you far. Square notebooks. So your graph and then the graph. Graph. Yeah, graph. Yeah.
You know where to find good ones? Because,
What, graph paper?
well, I want the graph paper to be a bit bigger so that I can make other ones.
Oh. Staples has it.
Yeah.
Like, bigger?
Yeah.
Bigger than that? I think Staples and, Staples, Walmart bookstore even. Do they have any bookstore? I know there were years they didn't have any.
Bookstore does have graph paper, it's just not with the other.
Right, take a look, I don't know, see if you like it.
It's like right across from the.
They have the chemical
They do, but they don't have the isometric, which I need for engineering.
Yeah.
Okay, let's take a look at this. Since I will be working both methods out, I don't know, I'll pick, I guess, disk first and then shell. But then we'll see which one was easier. And then I will also argue which one is easier immediately. whatever is easier, I don't care. I'll do both. I'll do disk first and then shell. I have to get the same answer. What I want to say now is that I will tell you which one is easier once the picture is done. So immediately I know as soon as I see that. So remember, draw big every time. So I have y equals 8. That's y equals 8. I have x equals 2. Rotation is on x. I have x equals 0. And I also have 2x plus 2. The slope is 2 over 1, 2 over 1, so it goes right there. So now, the function has to touch y equals 8, has to touch, so it has to be this piece here, the trapezoid, right here. So I'm telling you right now that disk method is going to be easier because it will only have one integral, and the shell method will be harder because it will have two integrals, and both of these methods are possible in this case because you don't get the situation where the rectangle goes between the same function ever, right? So when you have that happen, then you have to eliminate that particular rectangle. Over here, since I just said that I'm going to do disk first, let's do that blue. Remember that the disk method is always perpendicular to the axis of rotation. Axis of rotation is x, and then you see that this is perpendicular to it, right? So now, for this particular problem, I will set up, so disk first. I will say, and that worked out to be easier in this case, is single pi from 0 to 2. The top function is the one that is further away from axis of rotation, in our case 8, which is 8 squared, minus the linear piece, which is 2x plus 2 everything squared, and then the x. So representative rectangle that it's vertical is always dx, and that's how I know that it's dx, so all my functions and limits have to be in terms of x. Let me repeat that one more time. The chain of thoughts in my head, it's always the same for these problems. First, I ask myself, which ones, dy or dx, which one can I draw? Can I do both, or do I have to use one or the other? So that's my first question in my head. Once I know that I'm doing dx, then that dx governs the rest of the integral, because now variable is said to be x, functions have to be in terms of x, and limits have to be x. Because the integral has to match x, 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 x. They all have to be the same in terms of same variable all the time. So there is no doubt about that. All of them have to match. So now, let's go with, this is a 0 limit. So now we just need to compute this. That's pi integral 0 to 2, 64 minus 4x squared. That's 4/8, so minus 8x, and then minus 4, because there's that subtraction there. And that's going to be pi integral 0 to 2, 64, so that's 60 minus 4x squared minus 8x dx. So now what we get is pi integral, so we are now integrating, so 60x minus 4/3 x cubed minus 8/2 is 4x from 0 to 2. We don't have to plug in 0. Which 4?
Like 64 minus 4x squared. Then you went down.
This one?
No, the other one. Oh, you subtracted 4?
64 minus 4 is
Okay,
60 over here. It's magic. So we're plugging in 2, so we have pi integral that's 120. So that's 8 times 432 over 3 and minus 8. It's 4x squared. Who said 4x? Someone gave me the wrong information. Yeah, thank you. So that's it. Okay, so 120 minus 16 is 104 times 3, 312 minus 32. Let's say it's good. And then 2 plus 8 is 10, not divisible by 3. So I'm just going to leave it at 280 pi over 3. Is that what you have?
Not even close.
Well, now we're going to do shell, and hopefully it matches. So we can just drop the mic and leave. So for shell, need 2 integrals. Why do I need 2 integrals? Observe what's happening with the shape, guys. As I draw dy, because I know that for shell I need dy, you see how the dy that I draw on top and the bottom do not have the same function on the right. So I have to do one integral up to the point where they switch, and then do the other integral above, and then add them. So since I have such an awesome picture, I can just read the limits off of the picture. I don't have to compute anything. This is clearly 2. This is clearly 6. And that's on top is 8. What happened by 2? All right. So 2 integrals. Volume is going to be 2 pi integral, and the first representative rectangle swipes from 2 to 6. 2 to 6, and I have y, which is the position. And now I have to go and figure out what is this function flipped into a y. So that's y minus 2 is equal to 2x, from where x is equal to divide by 2. So 1/2 y minus 1. So 1/2 y minus 1. dy, that's the first one, plus 2 pi, second one is 6 to 8. And we have a very simple, it's just 2 times 2 dy. Right, because this, so this function here is x equals 2 in terms of y, and this function here is x equals to 1/2 y minus 1. And on this side, the function is always x equals 0. That's the y axis. So now, all I need to do is to compute this. This is times, not, maybe I should just put parentheses. So all I need to do is compute this. I better get 280 pi over 3. So volume is 2 pi, integral 2 to 6, and I have 1/2 y squared minus y to integrate. And for the second integral, I'm going to kick 2 outside. So it's 4 pi integral of y dy from 6 to 8. So volume is 2 pi. Our integration inside is 1 over 6y cubed minus 1/2 y squared from 2 to 6 plus 4 pi second integral is 1/2 y squared computed from 6 to 8. In order for us to compute this easier, you can factor out 1/2 on the first integral and cancel the 2 in front. So you will have pi y cubed over 3 minus y squared from 2 to 6 to compute. And on the second one, kill the half, so plus 2 pi y squared from 6 to 8. Come on, 280 pi over 3. So plug in 6. When I plug in 6, I get 6, so that's 36 times 272. Minus 36, plug in 2 is 8/3 plus 4. And then we have plus 2 pi, 64 minus 36. I hope. We can actually factor out pi. Let's do one thing at a time. So 72 minus 36 is 36 plus 4 is 40. So pi times 40 minus 8/3 plus 2 pi, and then 64 minus 36 is? Very good. All right. So now we can factor out pi, and we get 40 minus 8/3 plus 56. And that's 96. So pi times 96 over 1 minus 8/3. So now 96 times 3. So that's 270, 288. Oh yeah. Boss. So for this picture, we had, for this particular setup, graphs, we have functions. We have disk method, single integral, shell method, 2 integrals. If the tables are turned, you might have two disk integrals, 1 shell. Can be any combination. And you saw a previous example, which was that disk was not possible at all. We were forced to use shell. Obviously, you have problems where shell is not possible, and you must use disk. So all of those combinations are possible, and it just, warrants you to do 5,000 of these exercises to see many combinations. Everything starts with a graph. If you can't graph it, forget about it, because your method depends on either what's possible or what's easier, and you see that when you draw a representative rectangle. If you have no graph, you have nothing to draw. In certain situations, without the graph, you're not sure what to put on top, what to put on the bottom for integrals. In some cases, you might be integrating the wrong region, which is also bad. There's so many possible mistakes and pitfalls here if you don't have the correct graph. It's unbelievable. So practice that graphing part so that you know which one is the good. So I'll go back to this graph one more time and show that the blue line stretches always between the two same functions. So one on the bottom never changes for the entire existence of that blue representative rectangle. So it will start here, it will shift to the other side, the top always touches 8, and the bottom always touches the linear. So that's the reason why it's a single integral, because the top and the bottom of the representative rectangle write same functions all the time. Now, when you do the shell, when you attempt the shell method for this problem, you see that this side is always fine, but the other one changes the function. Function changes from x equals 1/2 y minus 1 to 2. So you get one integral for this piece, and then at 6 you get the other integral because other different functions are involved in your calculation. The limits go from 2 to 6 for the first one, because that's where the representative rectangle exists. It exists from 2, and then it dies at 6, because that's the portion that it swipes. And then the new integral starts at 6 to 8 in limits, because the representative rectangle for the top portion is going to start at 6 and swipe all of the values up to 8. The process of thinking is you draw the picture, the graph, you decide what region is, then you decide whether dx or dy, which will combine with the axis of rotation, tell you whether it's disk or shell. Looking at the first example, for the both methods, I did that with 2 and a 7. You clearly see that for that particular problem, both are easy and possible, disk and shell. Problem with parabolas, problem 6, we saw that it's impossible to use one of the two methods because you couldn't draw representative rectangles at all. And then this problem was one method is more annoying than the other. So those are the combinations. And then if you understand how these representative rectangles work, setting up these problems and working out these problems would be a joke. That's it for this section. We'll take a short break, and then 6.5, catching up. Bye.